In this video, I will be explaining how we solve this induction question in front of you. So first, we must start by declaring the proposition. So let P of n, where P is the proposition of any number n, is, so not is, but b sine x plus sine 3x plus dot dot dot. This is essentially just to signpost that instead of writing out the entirety of the of what we have to prove, we're going to write it as P of n later on. This makes it much easier and makes it short and easier later on. So we have let P of n be this when n is a positive integer, because that's what we have over here. Now we also have x is not equal to k pi, where k is an integer, but we don't need to include that when it comes to proving. So first, because we have to prove the smallest positive integer, we're going to use 1. So let n equal 1. So first we have to sub in n as 1. So we have sine 2 times 1 minus 1 x is equal to 1 minus cosine 2 times 1 x over 2 sine x. Now this is a simple calculation. We get sine of x is equal to 1 minus cosine 2x over 2 sine x. Now we only take one side to prove it equal to the other side. So in this case, we're going to take the right hand side. So we can write this as 1 minus, and in brackets, because of the trig identities, cosine 2x can be written as 1 minus 2 sine squared x. This over 2 sine x. Then removing the brackets, we get 1 minus 1 plus 2 sine squared x over 2 sine x. Now we can cancel the 1 and minus 1. And over here we have 2 sine squared x, 2 sine x, 2 gets cancelled, and the square gets cancelled, which leaves us with sine x, which is equal to the left-hand side. So we can say that P of 1 is true. Now, for induction, we have to prove it for 2 consecutive numbers, and in this case, 2 consecutive positive integers. So let n equal k, and we're taking k as any random positive integer. So we're going to write out the proposition again. So sine of x plus sine of 3x plus dot 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 sine of, now over here we have 2n minus 1. So this would be 2k minus 1x is equal to, so 1 minus cosine 2nx, and n is k. So it will be 1 minus cosine 2kx. So 1 minus cosine 2kx over 2 sine x. Now, to prove P of n as true for the next integer, we're just going to assume that, so assume P of k is true. So this is just a stepping stone to help us solve for the next integer. And because we don't know exactly what integer k is, we're just going to use k plus 1. So let n equal k plus 1. Now, once again, we're going to write out the proposition. So sine of x plus sine of 3x plus sine of, now over here, one might be tempted to directly sub in k plus 1, but it's important that we first sub in k, because that is what we're going to substitute in later on. So for now, we should write sine 2k minus 1x. And now we can sub in n as k plus 1. So that's plus sine 2k plus 2 minus 1x, because we did 2 times k plus 1, which is 2k plus 2. So I've just put that in here. So that's equal to 1 minus cosine, and in brackets 2k plus 2x, because we had to sub in k plus 1 and it's 2 of n. So 2 times k plus 1 is 2k plus 2 over x. And that's over 2 sine x. Now, given that p of k is true. So over here, when we first wrote out the proposition for p of k, we said assume that it's true. So that will help us in solving this. Now, for this entire part is present in p of k, and since we have assumed that that is equal to this, so the left hand side is equal to the right hand side, we can sub in the value we have for the right hand side. So that is 1 minus cosine 2kx over 2 sine x plus sine 2k plus 2 minus 1. Actually, we can simplify this and just write it as 2k plus 1x is equal to 1 minus cosine 2k plus 2x over 2 sine x. So far we have this. So we have n is equal to k plus 1, and we have assumed that p of k is true, and we have subbed the value we found for the right hand side, or we had for the right hand side of p of k, into p of k plus 1. So now it's all about simplifying this down and finding this value. Now to solve this question, we will take the left-hand side and equate it to the right-hand side. So if we take the left-hand side, we have 1 minus cosine 2kx over 2 sine x plus sine 2k plus 1x, and we must equate that to the right-hand side. So we first are going to multiply 2 sine x with sine 2k plus 1x. That gives us 1 minus cosine 2kx plus 2 sine x times sine 2kx plus x. So I'm just taking the x inside to make it easier, all over 2 sine x. Now, first, to make this simple, we can look at what we have to prove, and we see that the 1 minus and the 2 sine x are essentially untouched. So that immediately gives us a clue that everything that we have to do is in the cosine 2kx plus 2 sine x sine 2kx plus x. So only these terms have to be dealt with. So let's first use the trig identities and expand sine 2kx plus x out. So we have 1 minus cosine 2kx plus 2 sine x, and then let's open up a bracket over here. So then to expand this, we use the identities, and we get sine 2kx times cosine x plus sine x cosine 2kx. And that is over, so that's more, 2 sine x. Now we can expand, open up the brackets, we get 2 sine x cosine x sine 2kx plus cosine 2kx times 2 sine square x. Now I've kind of shifted the terms around, but it'll make more sense as we continue to solve this question. So this is all over 2 sine x. Now, first off, we see that we have a cosine 2kx here and a cosine 2kx here, but we have a minus over here. So what we can do is write this as 1 plus cosine 2kx multiplied by 2 sine square x minus 1 for this term, plus, and over here we have a 2 sine x cosine x. That's another trig identity of sine 2x times sine 2kx. Now, and yeah, over 2 sine x. Now, we're not going to cancel anything out when we count right now, but so we know that the 1 and the 2 sine x remain. Next, 1 plus cosine 2kx. Now, what we can do is multiply the entire thing by minus 1. So this would give us minus cosine 2kx, and the inside of the bracket would become 1 minus 2 sine square x plus sine 2x times sine 2kx all over 2 sine x. This is equal to 1 minus cosine 2kx. This trig identity gives us cosine 2x plus sine 2x times sine 2kx all over 2 sine x. Now, over here, we're supposed to prove 2k plus 2x or 2kx plus 2x. And we know that that identity would have a negative between the two multiplied terms. So what we can do over here is write this as 1 minus cosine 2kx times 2x minus sine 2x sine 2kx over 2 sine x. And using the trig identity we already know of the compound angle identities, this can be written as 1 minus cosine 2kx plus 2x over 2 sine x. This can finally be written as 1 minus cosine 2k plus 2x over 2 sine x, which therefore is equal to the right hand side and means that p of k plus 1 is true when p of k is true. Now we have to give a final statement that sums up what we have done. So as p of 1 is true and p of k plus 1 is true given p of k is true. We have to mention that because without p of k plus 1 cannot be proven. So as p of 1 is true and p of k is true, p of n is true for n belongs to, so n is any positive integer, and that is how you solve that question.